Hi again, this is circle theorem number 3. This theorem is about two angles sitting on the same arc at the circumference. Currently you can see I've drawn two angles, the blue one here, CDB, so the angle's at D, and the angle CEB, that's the angle formed at E there. If I draw the arc from C to B, you can see that both these angles, the blue angle and the red angle, are sitting on the same arc. That is, they start and finish at the same points. They both start at C and finish at B. If I look at angle CDB, the blue angle, it comes up at 65 degrees, and the red angle, angle CEB, you can see is also 65 degrees. So these two angles are equal. What happens if I move E around? As we saw in theorem 1, moving the angle, the point of the circumference on the same arc doesn't actually change the angle, because the opening or the arc there is still the same gap. The position doesn't change. I can actually move E over here so it actually sits on D. You can see they're the same. But wherever I move E to, the angle stays the same. Likewise, if I move the point D around in the circle, as long as it's still on the circumference, it'll have the same measure because it's still in the same opening of the arc. If I move point B, then the angles will change because the size of the arc is changing. But you'll note, it doesn't matter where I move point B to, both the angles remain equal. So the theorem is two angles at the circumference sitting on the same arc, will be equal. So if we go to our notes booklet now and fill in our notes, in this example here we've got two angles both sitting on the arc P to Q. You can see angle PSQ is sitting on the arc PQ, and the angle PRQ is also sitting on that same arc. So the theorem says that angles at the circumference standing on the same arc are equal. So what we need to do here on our notes, we should first say that angle PSQ is equal to angle PRQ, and simply then we can say x equals 41 degrees because those two angles are equal. Thank you.